Yes, it is legal to change wire size in a circuit. The National Electrical Code, or NEC, does not require that the same wire size be used throughout a circuit. However, there are certain conditions that must be met when changing wire size. Firstly, the wire size must be adequate for the ampacity of the circuit. The ampacity of a wire is the maximum amount of current that it can safely carry. The ampacity of a wire is determined by its size, material, and temperature rating. Secondly, the wire must be protected by a circuit breaker or fuse of the appropriate size. The circuit breaker or fuse must be sized to protect the wire from overheating. Thirdly, the wire must be properly spliced. The splice must be made in a manner that is both electrically sound and mechanically secure. In the example you provided, it is legal to use number 10 wires from the panel to the junction box and number 12 wires from the junction box to the branch circuits. The number 10 wires must be sized for the ampacity of the circuit, and the number 12 wires must be sized for the ampacity of the branch circuits. The wires must be protected by circuit breakers or fuses of the appropriate size, and the splices must be properly made. The following sections of the National Electrical Code address the requirements for changing wire size in a circuit. NEC Section 310.15. He states that conductors of different sizes shall not be used in the same circuit unless the larger conductors have been reduced in size at the point of connection to the smaller conductors. NEC Section 408.3. B states that conductors of number 12 American wire gauge and larger shall be spliced or joined with approved splicing devices. Conductors of number 14 American wire gauge and smaller shall be spliced or joined with approved splicing devices or by the use of a twist-on wire connector listed for the purpose. NEC Section 408.15 states that conductors shall be protected against physical damage. Where conductors are run through holes in studs, joists, or rafters, the hole shall be smooth and free from projections that could damage the conductor. Now let's delve into a more detailed explanation of these concepts. When selecting a wire size, you must consider the ampacity requirements of the circuit. Ampacity refers to the current carrying capacity of a conductor expressed in amps. The National Electrical Code provides tables, such as Table 310.15. B16, that lists the ampacities of various wire sizes based on their insulation type and operating temperature. It's important to choose a wire size with an ampacity that meets or exceeds the calculated load of the circuit. For example, a 20 amp circuit generally requires at least number 12 American wire gauge copper wire with a 75°C insulation rating as per NEC Table 310.15. 816. This table shows that number 12 American wire gauge copper wire with a 75°C insulation is rated for 25 amps, which is sufficient for a 20 amp circuit. However, other factors such as ambient temperature and the number of conductors in a raceway may require adjusting the ampacity. The National Electrical Code provides correction factors and adjustment factors to account for these conditions. For instance, if the ambient temperature is higher than 30°C, a correction factor is applied to reduce the ampacity of the wire. Similarly, if multiple current-carrying conductors are bundled together in a raceway or cable, an adjustment factor is applied to reduce the ampacity to prevent overheating. The National Electrical Code also specifies the minimum wire size for certain applications. For example, number 14 American wire gauge copper wire is generally the smallest size allowed for branch circuits supplying general lighting and receptacle outlets, while number 12 American wire gauge copper wire is typically required for 20 amp circuits. In situations where you are changing wire sizes, it's crucial to ensure that the smaller wire size is adequately protected by the circuit breaker or fuse. The overcurrent protection device should be sized to protect the wire with the lowest ampacity in the circuit. For instance, if you're transitioning from number 10 American wire gauge wire to number 12 American wire gauge wire, the circuit breaker should not exceed 20 amps to protect the number 12 American wire gauge wire. A properly sized overcurrent protection can lead to overheating and potentially a fire hazard. When splicing wires of different sizes, it's essential to use appropriate splicing methods and connectors that are listed for the purpose. The National Electrical Code requires that splices be electrically sound and mechanically secure. This means that the splice must provide a reliable electrical connection and be strong enough to withstand mechanical stresses. Twist-on wire connectors, also known as wire nuts, are commonly used for splicing smaller gauge wires, while crimp connectors or mechanical connectors are often used for larger gauge wires. It's important to follow the manufacturer's instructions when installing these connectors to ensure a proper and safe splice. In addition to these general requirements, the National Electrical Code also addresses specific situations where wire size changes may occur. For example, Section 240.21 addresses the protection of tap conductors, which are conductors that are tapped from a larger feeder conductor. This section specifies the conditions under which tap conductors are allowed and the requirements for their overcurrent protection. Understanding these requirements is crucial for ensuring the safety and compliance of electrical installations. Let's consider some examples to illustrate these concepts. Suppose you have a 30 amp circuit that is initially wired with number 10 American wire gauge copper wire. However, due to some modifications, you need to extend the circuit using number 12 American wire gauge copper wire. In this case, you would need to ensure that the circuit breaker is reduced to 20 amps to protect the number 12 American wire gauge wire. You would also need to use appropriate splicing methods to connect the number 10 American wire gauge wire to the number 12 American wire gauge wire. Another example could be a situation where you're installing a subpanel in a detached garage. You might run a larger gauge wire from the main panel to the subpanel to account for the total load of the subpanel. However, the individual branch circuits in the subpanel may require smaller gauge wires. In this case, you would need to size the feeder wire to the subpanel based on the total load and ensure that each branch circuit is protected by an appropriately sized circuit breaker. In addition to the National Electrical Code requirements, it's also important to consider local codes and regulations. Some jurisdictions may have additional requirements or restrictions on wire size changes. It's always best to consult with a qualified electrician or electrical inspector to ensure that your electrical work complies with all applicable codes and regulations. Furthermore, it is important to highlight the significance of proper workmanship when making wire size changes. A poorly executed splice, for instance, can lead to a loose connection, which in turn can cause arcing, overheating, and potentially a fire. Therefore, it is essential to take your time and ensure that all splices are made correctly, using appropriate tools and techniques. This includes stripping the insulation properly, making a secure mechanical connection, and using the correct type of connector for the wire size and application. When working with aluminum conductors, it is particularly important to use connectors that are specifically listed and labeled for use with aluminum. Aluminum expands and contracts more than copper with temperature changes, which can lead to loose connections if the wrong type of connector is used. Antioxidant compounds should also be used when connecting aluminum conductors to prevent corrosion. Another important consideration is the voltage drop in a circuit. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. The National Electrical Code recommends limiting the voltage drop in branch circuits to 3% and in feeder circuits to 5%. The voltage drop in a circuit is affected by several factors, including the wire size, the length of the circuit, and the amount of current flowing through the circuit. Using a larger wire size can reduce voltage drop, but it may not always be practical or cost-effective. Another option is to shorten the length of the circuit or reduce the amount of current flowing through it. There are several online voltage drop calculators that can help you determine the appropriate wire size for a given circuit based on these factors. When making wire size changes, it's also important to consider the physical protection of the conductors. The National Electrical Code requires that conductors be protected against physical damage. This can be accomplished by running the conductors in conduit, cable trays, or other approved raceways. When running conductors through holes in studs, joists, or rafters, the holes must be smooth and free from projections that could damage the conductor. Metal plates or bushing should be used to protect conductors from sharp edges. In some cases, it may be necessary to use a larger conduit or raceway to accommodate the larger wire size. The National Electrical Code specifies the maximum number of conductors that are allowed in a given size of conduit or raceway. It's important to consult these tables to ensure that you're not exceeding the fill capacity of the conduit or raceway. Exceeding the fill capacity can make it difficult to pull the conductors through the conduit or raceway, and it can also lead to overheating. Another important aspect to consider when changing wire size is the labeling and identification of the conductors. The National Electrical Code requires that all conductors be properly identified as to their purpose and voltage. This can be accomplished by using color-coded insulation or by marking the conductors with tape or labels. When changing wire size, it's important to ensure that the new conductors are properly labeled and identified. This will help to prevent confusion and ensure that the electrical system is safe and easy to maintain. In addition to these practical considerations, it's also important to be aware of the legal and regulatory requirements related to electrical work. Electrical work is typically regulated by local and state codes, and it's important to obtain the necessary permits and inspections before starting any electrical project. Working without a permit or failing to comply with the electrical code can result in fines, penalties, and even legal action. It's also important to hire a qualified electrician to perform any electrical work that you're not comfortable doing yourself. A qualified electrician will have the knowledge, skills, and experience to ensure that the electrical work is done safely and in compliance with the electrical code. When hiring an electrician, be sure to check their credentials and references. You can also verify the license status with the local licensing board. In summary, changing wire size in an electrical circuit is permissible under the National Electrical Code, provided that certain conditions are met. These conditions include ensuring that the wire size is adequate for the ampacity of the circuit, protecting the wire with an appropriately sized circuit breaker or fuse, and properly splicing the wires together. It's also important to consider factors such as voltage drop, physical protection of the conductors, and labeling and identification of the conductors. By following these guidelines and consulting with a qualified electrician, you can ensure that your electrical work is safe, compliant, and reliable. Always prioritize safety when working with electricity. Turn off the power to the circuit before making any connections or modifications. Use appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical equipment when you're wet or standing in water. Electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from injury or death. Remember that the National Electrical Code is a complex and comprehensive document, and it's not possible to cover all aspects of wire size changes in a single explanation. It's important to consult the National Electrical Code directly for the specific requirements that apply to your situation. You can also find helpful information on the websites of organizations such as the National Fire Protection Association and the International Association of Electrical Inspectors. By staying informed and following best practices, you can ensure that your electrical work is safe, reliable, and in compliance with all applicable codes and regulations. Keep in mind that electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest changes. You can do this by attending continuing education courses, reading industry publications, and participating in professional organizations. By investing in your knowledge and skills, you can become a more competent and confident electrical professional. Finally, always remember that safety is paramount when working with electricity. Never take shortcuts or compromise on safety in order to save time or money. The potential consequences of electrical accidents can be severe, and it's simply not worth the risk. By following the National Electrical Code, using proper techniques, and prioritizing safety, you can help to prevent electrical fires, injuries, and fatalities.